All right, let's dive right in. If you're on an environmental reporting team in the oil and gas midstream sector, you know that accurately disclosing air quality metrics isn't just a suggestion, it requires absolute precision. Today, we're unpacking exactly how to navigate SASB standard EMMD 120A.1. We are going to make sure you have the exact boundary awareness and the specific chemical definitions you need to get your reporting absolutely right. So, as you probably already know, navigating the SASB framework today means understanding that these standards are now maintained by the International Sustainability Standards Board, or the ISSB. This transition basically means these metrics are increasingly foundational to global sustainability reporting. Your goal? Ensuring your midstream operations meet the exact criteria for the specific accounting metric known as EMMD 120A.1. Here is our roadmap for this explainer. First, why air quality matters. Then, the core four pollutants, reporting NOx and SOx, defining VOCs and PM10, approved calculation methods, and finally, the bottom line. Okay, let's start with Section 1, why air quality matters, local risks and financial impacts.
What's really interesting here is how explicitly the standard calls out midstream emissions for creating acute risks to nearby communities. In the midstream sector, you're constantly dealing with compressor engine exhausts, oil and condensate tank vents, and natural gas processing, right? Well, these activities release air pollutants that can create significant and highly localized environmental or health risks. The standard zeroes in on this specifically because these localized impacts are exactly what draw heavy regulatory and public scrutiny.
And this is absolutely crucial. Active air quality management isn't just some exercise in compliance. It's a direct pathway to realizing real operational efficiencies. Now, obviously, the financial consequences your entity faces will vary depending on your specific locations and the prevailing regulations there. But the standard makes a clear case. If you actively manage your air quality through technological and process improvements, you can literally mitigate the adverse financial effects of regulations. Ultimately, managing these emissions effectively creates a much lower cost structure for your organization over time.
Moving right along to Section 2, the core four pollutants your reporting mandate. Okay, here's the absolute core of the metric. You've got to report your total direct air emissions into the atmosphere for four specific categories. And please take careful note of the unit of measure here. You must report this strictly in metric tons per pollutant, nothing else. You'll be compiling metric tons for nitrogen oxides, sulfur oxides, volatile organic compounds, and particulate matter. We'll break down the exact chemistry of each one of those in just a second. But before we get into the chemistry, we need to talk about boundaries. You have to ensure your reporting boundary is totally comprehensive. The scope of your disclosure includes air pollutants resulting from literally all of your entity's activities and sources of emissions. That means capturing direct emissions from everything across your entire midstream footprint. We're talking stationary pipeline compressor engines, your production facilities, mobile sources like your tank truck fleets, and yes, even the emissions associated with your office buildings. It's a complete total operational footprint metric. Which brings us to Section 3, reporting NOx and SOx, critical inclusions and exclusions. Now, for your oxides of nitrogen, reported as NOx, you've got to be incredibly precise. The standard is extremely clear on the scope here. While nitric oxide, or NO, and nitrogen dioxide, NO2, must be calculated and included in your total, nitrous oxide, N2O, is strictly excluded from your NOx metric ton total. You really need to ensure your calculation systems are filtering these out correctly. On the flip side, for oxides of sulfur, reported as SOx, your disclosure scope is actually a bit more straightforward. The standard just requires the inclusion of both sulfur dioxide, SO2, and sulfur trioxide, SO3. Obviously, these are of particular concern in the midstream industry, and capturing both accurately is an absolute requirement for compliance. And just a quick reminder, as you compile the data for these metric tons, keep in mind that the SASB standard explicitly states your methodology should align with established industry guidance. Specifically, your emissions disclosures must be consistent with the APICA, API, and OGP sustainability reporting guidance for the oil and gas industry. This is just to ensure we have apples-to-apples comparability across the entire sector. All right, Section 4, defining VOCs and PM10, precision in categorization. Let's look at non-methane volatile organic compounds, or VOCs. The standard defines this as any compound of carbon that participates in atmospheric photochemical reactions. But watch your exclusions really carefully here. You do not include carbon monoxide, carbon dioxide, carbonic acid, metallic carbides or carbonates, or ammonium carbonate. And Crucially for this sector, you completely exclude methane. Plus, you also exclude any compounds designated under applicable jurisdictional laws as having negligible photochemical reactivity.
Now, here's a really interesting built-in flexibility for reporting teams. We all know midstream operations often cross multiple regulatory boundaries. If the applicable local jurisdictional or regulatory definitions of VOCs conflict with the SASB definition we just covered, you are totally allowed to define VOCs in accordance with that local legal definition. However, and this is a big however, if you use this exception rule, you absolutely must transparently identify and disclose the source of the definition you are using in your reporting.
Okay, for your PM10 disclosure, the focus is entirely on the microscopic size of the particulate. PM10 is defined as any airborne, finely divided material with an aerodynamic diameter less than or equal to a nominal 10 micrometers. What's super important to note here is that this applies regardless of whether the material is a solid or a liquid. If it fits that aerodynamic diameter criteria, it goes right into your metric ton calculation.
Section 5, Approved Calculation Methods.
So once you know what to track, how do you actually measure it? Well, the standard gives you distinct approved methodologies for generating your metric ton data. The entity may discuss the calculation method it uses for its emissions disclosure. Your accepted approaches include pulling data directly from continuous emissions monitoring systems, or SEAMs, utilizing established engineering calculations, or employing mass balance calculations. It's basically a toolkit. Choose the methodology that best fits your specific operational infrastructure, but just be prepared to disclose exactly which method you used to arrive at your numbers.
And finally, Section 6, the bottom line, operationalizing compliance.
As you go out and gather your metric tons for NOx, SOx, VOCs, and PM10, I want you to consider this. Precise emissions tracking isn't just about regulatory defense, and it isn't just about satisfying the SASB framework. It actually provides the exact baseline data your organization needs to identify hidden inefficiencies, optimize your processes, mitigate localized risks, and truly modernize your midstream operations for a significantly lower cost structure in the future. Accurate reporting is literally the first crucial step to active management. Thank you so much for joining me for this explainer, and best of luck with your disclosures.